When a smoke detector is powered by its battery backup and an arc fault circuit interrupter, or AFCI, trips, the battery backup will not provide sufficient signal for the traveler wire to activate all interconnected smoke detectors. Only the individual smoke detector that detects smoke will activate. To understand why, it's important to consider how interconnected smoke detectors and AFCIs function. Interconnected smoke detectors are designed to communicate with each other so that when one detects smoke, all the others sound an alarm. This is typically achieved through a traveler wire, which carries a signal between the detectors. This signal is usually a low-voltage alternating current, or AC, signal that is activated when a detector senses smoke. An AFCI is a type of circuit breaker that protects against arc faults, which are dangerous electrical conditions that can cause fires. When an AFCI detects an arc fault, it trips, cutting off the power to the circuit. Now let's consider what happens when an AFCI trips on a circuit with interconnected smoke detectors that are also equipped with battery backups. Firstly, when the AFCI trips, it disconnects the AC power supply to the smoke detectors. This means that the smoke detectors will switch to battery backup power. Secondly, the battery backup in a smoke detector is designed to power only that individual detector. It's not designed to provide enough power to send a signal through the traveler wire to activate all the other detectors in the system. The battery's primary function is to ensure the detector continues to function during a power outage, providing localized detection and alarm. Thirdly, the traveler wire requires a certain voltage and current to transmit the alarm signal effectively. The 9 volts battery backup in a typical smoke detector provides power for the local alarm sounder and the smoke detection circuitry, but it does not provide sufficient power to drive the traveler wire and activate all the other interconnected alarms. The signal strength from the battery is insufficient to propagate through the traveler wire and reliably trigger the other detectors. Consider a scenario where a smoke detector detects smoke and its battery backup kicks in after the AFCI trips. The detector will sound its local alarm, alerting anyone in the immediate vicinity. However, because the battery backup doesn't provide enough signal to the traveler wire, the other interconnected smoke detectors won't sound an alarm unless they also independently detect smoke. It is crucial to understand that testing smoke detectors should be performed regularly to ensure they function correctly. During testing, if you simulate smoke exposure, only the detector directly exposed should activate if the AFCI is tripped and the detector is running solely on battery backup. If all detectors activate, it could indicate that the AFCI did not completely cut off the power, or that the detectors are wired in a way that bypasses the AFCI protection, which is a safety hazard. Understanding the specific role and limitations of battery backups in interconnected smoke detector systems is crucial for ensuring effective fire safety. The primary purpose of the battery is to provide localized alarm functionality during power outages, not to activate the entire interconnected system. For reliable interconnected alarm functionality, the system relies on the standard AC power supply when it's available. Furthermore, it is essential to understand the limitations of battery backups in smoke detectors. The battery is primarily designed to provide power to the local alarm and detection circuitry of the individual smoke detector. It's not designed to transmit a signal strong enough to activate all the other interconnected alarms in the system. Let's delve deeper into the technical aspects of the traveler wire and the signal it carries. The traveler wire typically requires a voltage level that is provided by the main AC power source. When the smoke detector is running on battery backup, the voltage provided by the battery is not sufficient to activate the traveler wire and send a signal to all the other interconnected alarms. The battery is simply not designed to provide that level of power. Now let's consider the implications of this for testing and inspection purposes. When testing smoke detectors that are interconnected, it is important to ensure that the AFCI is functioning correctly and that it trips when a fault is detected. If the AFCI is tripped and the smoke detectors are running on battery backup, only the detector that is directly exposed to smoke should activate. If all the detectors activate, this could indicate a problem with the wiring or with the AFCI itself. It's also important to ensure that the battery backups in the smoke detectors are functioning correctly. This can be done by testing the smoke detectors while they are running on battery backup. If the smoke detectors do not activate when they are running on battery backup, this could indicate that the batteries are dead or that there is a problem with the smoke detectors themselves. Regular testing and maintenance of smoke detectors are essential for ensuring that they function correctly and that they provide adequate protection in the event of a fire. This includes testing the smoke detectors on both AC power and battery backup, as well as inspecting the wiring and the AFCI to ensure that they are functioning correctly. Understanding the relationship between smoke detectors, battery backups, and AFCIs is crucial for ensuring fire safety. When an AFCI trips, the smoke detectors will switch to battery backup, but the battery backup will not provide enough power to activate all the interconnected alarms. Only the detector that is directly exposed to smoke will activate. This highlights the importance of having working smoke detectors on every level of the home, as well as regularly testing and maintaining the smoke detectors to ensure that they function correctly. Also, consider the role of the AFCI in preventing electrical fires. The AFCI is designed to detect arc faults, which are dangerous electrical conditions that can cause fires. When an AFCI detects an arc fault, it trips, cutting off the power to the circuit and preventing a fire from starting. By protecting against arc faults, AFCIs play a crucial role in ensuring the safety of homes and businesses. Furthermore, it is important to note that different types of smoke detectors exist, including ionization smoke detectors and photoelectric smoke detectors. Ionization smoke detectors are generally more responsive to flaming fires, while photoelectric smoke detectors are generally more responsive to smoldering fires. It is recommended to have both types of smoke detectors in a home to provide comprehensive protection against all types of fires. In addition to having working smoke detectors, it is also important to have a fire escape plan in place. A fire escape plan should include designated meeting places outside the home, as well as instructions on how to evacuate the home safely in the event of a fire. Regularly practicing the fire escape plan can help ensure that everyone in the home knows what to do in the event of a fire. It's also vital to know local fire safety codes and regulations, and to ensure that your home meets these requirements. These codes often dictate the placement and type of smoke detectors required, as well as other fire safety measures. Staying informed about these codes can help you maintain a safe living environment. To reiterate, the battery backup in a smoke detector is designed for localized operation during power outages. The power output is specifically tailored to activate the alarm and detection circuitry within that individual unit, and not to propagate signals through the interconnected wiring. Therefore, it is imperative to regularly test and maintain your smoke detectors, understand their functionality, and ensure that your home is equipped with a comprehensive fire safety plan. And always consult with a qualified electrician to ensure the correct wiring and installation of your electrical systems.